Okay, since previously we have learned about the alternative formula for batch and also flow reactor. Now we are going to learn about the sizing of Cstr and PFR. Both are flow reactors. Okay, flow reactors. Sorry, flow reactors. Okay, for an isotope reactor, the rate is typically greatest at the start of the reaction when the concentration is greatest. So we have learned this one as well. Okay, greatest at the start of the reaction. Okay, at the start. Here we have greatest start of the reaction. Concentration is greatest. Okay, okay. So the rate is greatest. Okay. So we can recall that the reactor volume for Cstr and PFR are a function of the inverse of the reaction rate. Why? Because we are going to look at the graph after this, okay, the Levin spill plot, okay. For all irreversible reaction of greater than 0 order, the volume of the reactor approaches infinity for conversion of 1, since the reaction rate approaches 0. Why? And the slope of Levin spill plot approaches infinity. In other words, Ra approaching 0 when x approaching 1. Okay, so we will look at the graph to have better understanding. Okay, so this is the Levin spill plot where the y-axis is Fa naught over negative Ra. Negative Ra is the rate of reaction. Okay, rate of reaction is the flow rate. Flow rate. X is the conversion for x-axis conversion. So if we look at this graph, what does it means? The reaction or the conversion at 1 at conversion approaching 1, the rate of reaction approaching 0. Okay, so if you look at this plot, okay, this is the curve. Okay, this is conversion equals 1. Okay, if we go this way, we will not touch this 1. It will go like this, so it will become infinity. Okay, and then why the rate is approaching 0? Because if we go up, okay, if the curve goes up, it means the reactants become lesser and lesser, right? So if we don't have enough reactant, means we will not have, the rate of reaction will become 0, will approaching 0, right? And then why we say the volume of the reactor approaching infinity? Okay, if you look at this graph, okay, this is the volume, right? This is if we consider as Cstr. Okay, if we have this means Cstr. Okay, this square or okay, okay, or rectangle. Okay, this will be the volume for Cstr. This whole thing. So if we are approaching 1 and the rate of reaction approaching 0, okay, which means we cannot have absolute volume of the Cstr, because this is depending on the this curve. In other words, I need to expand this graph. Okay, let's see. If we draw this graph, okay, okay, similar condition with previous previous diagram. Okay, so sorry, it will not touch 1, right? This is 1, and then the volume will keep on increasing, right? So that's why we call it as infinity. Infinity. If the reaction, if the curve goes up, and then the volume will go up as well. Okay, so there is no limit on the volume. Okay, no limit. So volume become infinity. Now let's look at PFR. Okay, we know that the formula for PFR is P equals F A naught. Okay, integration from 0 to x. Okay, dx over negative RA. So this is in term of integral, which means integral give us definition of the volume under the curve. This is the volume for PFR. Okay, so at 0.8 conversion, this will be the volume for PFR. Okay, this whole thing. But for CSR just now, it is in term of square or rectangle form because we have this formula, the algebraic formula, where we have FA naught minus FA over negative RA. So this is in term of algebraic form. If algebraic form mean we need to consider as the area of the square or rectangle. If it is 0.8, we need to go and then until it touch this line, then we go to this side. So this whole thing will become the volume for CSTR. So that's the difference between volume of CSTR and also PFR. Okay. Just now we agree that for CSTR, the volume will be infinity, right? Because of this. Okay, it cannot touch one here. It will not touch one. Okay, so it will go up and up and up and up. So we will have uh, uh, V approaching infinity. Okay, how about PFR? Okay, if we go to this is our PFR, the same condition. Okay, so this will become the limit at 1. Just now we have this as square, right, or rectangle. Okay, for PFR, this will be the volume. Okay, so the same thing happen here because since we cannot have infinite we cannot have finite value, so V will become infinity as well because it will go up and up and up. The same condition with CSR, but the area is under the graph. Okay. For reversible reaction, the maximum conversion is the equilibrium conversion where the reaction rate is 0 and thus the volume of the reactor approaches infinity for a system in equilibrium as well. So the same condition, the same thing happen for reversible reaction. For an isothermal case, the CSR volume will typically be greater than PFR volume for the same condition except when zero order. Okay, you can look at this video. I have shared it in bold as well. Uh, to know to have more understanding regarding zero order, and the same goes to CSR versus PFR, but I will explain to you um, the sizing of CSTR versus PFR based on several conditions. So if you look at this diagram, we have agreed that this whole thing will become the volume for CSTR. Then for PFR will become like this for x1. Okay, this is x1. For x2, x1 to x2, this will be the volume for CSTR. This will become the volume for PFR for x1 to x2. Then for x2 to x3, this will be the volume for PFR. Okay, this will become the volume for CSR. So in other words, if you look at this will be the volume for PFR. Okay, and then this will be the volume for CSTR. You need to add this one with this one and this one. So which one will have the greater volume? For sure is the STR, because the STR have more volume, right? Because it is more than the curve. For PFR it is area under the curve, but for CSTR it will goes up to this level. Okay, this for CSTR. So for this condition where we have um, decreasing rate of reaction, okay, so the volume of CSTR will be greater than PFR. We have how to explain on what we have learned just now is based on this formula. Okay, we have this formula: V equals FA naught 1 over minus RA XF minus XI, where F subscript stands for final and the I subscript stands for initial. Okay, and then if it is the first reactor in the series, then Xi equals 0. To achieve the same overall conversion, the total volume for 2 CSTR in series is less than required for 1 CSTR. This is not true for PFRs. Why it is not true for PFR? Because the formula for PFR is this one, and then if we have series of PFR where V total equals this, okay. So if we split into two PFR, so we will have 0 to x1, x1 to x2. So at the end of the day, it will become the same. The PFR can be modeled as infinitely many CSTR in series. Okay, this one we have, I have shared to all of you the video regarding many CSTR in series represents one PFR. Okay, how to explain it in a diagram? So we draw a diagram. Okay, we have this curve. Okay, for instance, we have this one as x1, x2, x3. Okay, so for CSTR, we have if for one CSTR, we will have this as the total volume, right? But for two CSTR in series, we will have this one plus with this one. So it is smaller than if we have one CSTR as compared to two CSTR in series. Okay, this will become there will be a gap here, which represent lower volume for CSTR in series as compared to one CSTR. Okay, for PFR, if we have this curve, okay, and then we have x1 here, x2 here, okay. So if we have integration from this to this will be the volume for first PFR, and then this will be the volume for second PFR. And then if we have one PFR, it will measure from here to here, so it will give the same volume, even though if you compare PFR in series as well as one PFR, so it will give the same volume. Last but not least, I just want to show you the difference between this type of curve and this type of curve. Okay, so if this curve will give, we have agreed that CSTR will have greater volume than PFR, right? Because of this, right? This whole thing, while PFR is this under the curve, the area under the curve. But for this one, CSTR will become like this. Okay, and then for PFR is area under the curve. So for this case, PFR will have greater volume than CSTR. So how to design a reactor? It depends on the curve of the reaction. Thanks for now.